Hey guys, welcome back to my channel. This is day 41 of uh algorithm challenge, and it's the follow-up to the dynamic programming second part where there is only one state variable. And this is my second try to this recording, and I've already recorded everything and now I'm starting from scratch. And due to that, I already have a code written here. So let me share my screen. Sometimes Zoom has this problem. I press share screen and I confirm that it is stating that I am screen sharing, but then it doesn't get recorded. But anyways, this is the code, but yeah, I'm just gonna go through it, explain how it works, and of course what the problem is. So we're gonna go through this problem, house robber. It's Leetcode 198. So we're basically a robber trying to rob houses along the street. Each house has a certain amount of money stashed. Only constraint stopping us from robbing each of them is that adjacent houses have security systems connected, and it will be automatically contacted to the police if two adjacent houses were broken into um, in the same night. So it's a bit similar to the problem that we have solved while introducing the theory yesterday, right? Only difference is that there we had to find the minimum amount of numbers in order to reach the top of the stairs. So, and we could only move once or twice along the array. Um, Whereas here we're trying to find the maximum possible amount of money, right? So as you can see from test case one, given an array of length 4, the output is 4 because we're going to start from index 0, and then since we cannot rob the house right next to it, we have to move 2 indexes. So from 1, we move on to 3. Let's say that if we start from index 1, then in this case, it's 2 plus 1, which is lesser than 4. So that's why we put it as output 4. Same goes for test case 2, where the length of the array is 5, and we start from index 1 because we know that on index 0, because we know that on index 2 there's the number 9, which is the maximum possible number in this array, and surely it's going to have higher possibility of reaching the maximum amount of money. So yeah, that is the logic behind this question. From yesterday, we looked at 3 different things that we have to define before solving the dynamic programming problem. And today, I just want to tell you guys that we're not going to use the top-down approach, but instead we're going to use the bottom-up approach, because I thought maybe um, for the variability and also for my sake and your sake, who's watching this video, it could be better to get used to different approaches. Plus, the bottom-up approach usually has a better time complexity, so it might help when asked to optimize the code. But the things that we have to define is same as um, when we had to do top-down approach. So the first one was we need to have a function that will compute the answer. Second is the recurrence relation to transition between the state variables. And third one is the base case. So firstly, our function that will compute the answer is dp to the index I. dp, since we're going to use a dynamic programming, and we know that the state variable is I, like most of the Leetcode questions. because we're trying to find the maximum amount of money that we can scavenge from the houses. And the amount of money is nums square bracket I, right? And nums here is the array that we are given with. So that was the function. Second, we have to define the recurrence relation to transition between the states. So we have two options. The first option is to not rob the house I. Then the max money is the same as dpi minus 1, because we know that we cannot take the money from the adjacent house. So we have to select the house that's at least 2 indexes further from the original house, left and right. Second option is to rob the house I. In this case, we cannot rob the house I minus 1. So the maximum money is the maximum of um, of dpi minus 2, right? I minus 2 and plus the nums I. So nums I, because we decided to rob the house I, and dpi minus 2 because we're still using the dpi minus 1, and since we're not no, that's a wrong explanation. We're using I minus 2 because we started from index I, and then from I, 2 indexes left and right is I minus 2, or I minus I plus 2, and we, in this case, we made it as I minus 2. So yeah, this is the recurrence relation. And finally, the base case is pretty simple. First, it's when the first house is the only house that we can rob. So in that case, we will return the amount of money in the first house, right? So that would be nums 0. Yeah. Yeah, actually, and if there's 2 houses, we return the maximum of the 2. So that would be dpi is maximum of nums of 0 and nums 1, right? dp1. So if we see, if we see the code now, it is using the bottom up approach. So first of all, we define the base case, which is when there's only one house, length of nums is 1. We return the amount of money in that house itself. So that's nums bracket of 0. After defining the base case, no, this, okay, this is not, it's just a method that checks if there's only one house. Okay, so we finished this part. Now we have to initialize the array. So n is the length of the nums, and dp is the array filled with 0. And this is what we did in sliding windows as well, just filling up the array with number of zeros. Now, these are the base cases. dp0 equals to nums 0. So base case for the first house is straightforward. The maximum amount of money that can be robbed is the money in the first house. And second case is when uh, rob the first house or rob the second house, but find the maximum of either one of them. So that's the second base case. Now we define the edge case, which when the length of the array is 1 and we only have one choice to make. We have defined two base cases. Now, because this is a bottom-up approach, we have to utilize the for loop instead of the recursive approach. So we start from range 2 because we have already defined the base case of 0 and 1 when the index is 0 and 1. So we skip that. We start from 2 already, and then we iterate until the end of the array, which is n. So here, dpi is the maximum of I minus 1. So we have already stated this recurrence relation. There are two choices: not robbing the first house, not robbing the current house, or robbing the current house. And for the first choice, the maximum amount of money is the same as I minus 1 because we cannot rob the adjacent one. And for the second choice, it is nums I, which is the current choice, current amount of money, the amount of money in the current choice, and the house, the amount of money in the house that is 2 indexes away, because we have to skip the adjacent house. So that is dpi minus 2. And now we just return the dpm minus 1 to find the answer. And let's try to run this code to see if this works. And yeah, voila, we have found the answer. You can see it fits 2 test cases. So yeah, that was it, guys. Although it's a medium level difficulty, it wasn't that hard because, like said yesterday, we have already we already have a knowledge of things that we have to define first, which are state variables, function, and recurrence relation. And we know the approach that we're going to take. Although it's going to be more difficult when we move on to the case where there are multi-dimensions instead of one state variables. But tomorrow we're going to explore that. So for today, this is it. Thank you guys all for watching. And if you guys have any questions or comments, please leave it down below.